All right, extreme values. The second day. Now I have to be nice. We're going to optimize on a closed interval. So yesterday we didn't do this, but today we might see something like this. Okay, so just a part of a function where that one might continue on, but we're only worried about what's in here. Okay. So critical points, you're okay with calculating critical points?
Yep.
All we're going to do is use those and the endpoints in the function to find the max value. Okay, so the critical points really are the hardest part of this. So if we do this function, let's make that a 2. Me? I did this morning. I have this problem with like burning myself, you know, on purpose. I don't know why. It's a stupid human trick is what it is. Self-mutilation. Okay, so we're going to optimize. So the question might say, find the extrema of that. Okay, so how do we calculate critical points? Okay, Ben, what's the derivative then? 7? I'm pretty sure that's not the right answer again. Eventually it might work. What's the derivative, Ben?
X squared minus 30x plus 24.
Oh, we have a new Ben in class. Welcome to class, new Ben.
Hello.
So can the old Ben go home?
The old Ben can just keep his mouth shut, I guess. Okay, so there's the derivative, right? Oh, we made this one really easy on you. I'm going to factor a 6 out. Yeah, but this is easier. It is. Done. Okay, those are my critical points, right? Is there anywhere that's not differentiable?
No.
No, it's differentiable everywhere, so.
Then is your maximum and your minimum just the highest critical point?
So,
No, I think it's doing this table.
so now we're just going to do a table to see what the max and min are. Okay, so I have 0 and 6 are the endpoints. We have to include the endpoints. And these are our critical points. I like to put them in order. Your book actually doesn't, which kind of bothers me, but I like to put them in order. Just me. It doesn't really matter. Now, here's the key. We're gonna start having tables like this that are 4 rows, 4 columns, messy. You have to pay attention to what this is, because sometimes it'll be F prime, sometimes it'll be F double prime. This time it's just F. So we actually have to plug it into the original equation. Okay? So if you plug 0 in, oh, we got one right.
Going home.
Yeah, you do that.
You're only like, you're 1 for 3.
Okay, so those are the numbers, because I know you can add, subtract, multiply, and divide. What's the max?
Oh, the Y max?
Yeah, the y is up or down, right? So that tells us higher or lower. So 43 is the highest point. And the lowest point is,
None of the problems on the homework level.
Wait, then why did you have to calculate the critical point?
because the critical points give you, so let's look at what this function does.
No, it's a point. Oh.
Yeah.
Oh, yeah, because that's a point. Okay. Get it.
Okay, so this is what that function looks like in that interval. It's just a sketch. So the critical points give us the low and the high, the dips and or the the waves and the troughs, and then the end points could possibly be higher. So that's what we're looking for. Right?
Right.
Was that one easy enough?
Yep.
Okay, let's try a harder one.
One is harder than any of them.
I'm gonna do homework. I do math and science.
On
Yeah, let's not get into data about life and time being reality, like the last class.
Yeah, that's my fault. I started that yesterday now.
I started it actually.
Oh, I brought up the star.
I brought up the number of atoms in the universe before that. Yeah, it was fun. It was fun.
It's funny. Thanks, you went to my mission all last
That's stupid.
Really?
Don't take that.
Okay, what's the derivative?
Oh, yeah, that's great.
What's the derivative?
Negative 2/3.
X minus 1,
Negative 1/3.
negative 2/3 to the negative 1/3.
No.
We don't need the chain rule because the inside derivative is 1. So it's the power rule. See the power rule?
How did you get negative 2/3?
Because it's,
1 minus.
ooh, yeah. It's negative here. So when you bring the 2/3 down, it becomes negative 2/3.
Oh, so it's 1 minus?
Yeah, 1 minus. So this is 0.
What if 1 minus? Oh,
The derivative of a constant is 0. So,
okay. Okay, that's
okay, what are the critical points?
wait. That's I thought you had to do derivative outside, copy inside, derivative inside.
What's the derivative of the inside?
Oh, never mind.
1. Yep. So we didn't write it down. But you are correct. Okay, so that's the function set equal to 0 and rewritten so that you can see it, right?
Yeah.
Is there ever a point where that equals 0? No. That makes it undefined, so
Yeah.
there are no solutions to that one. But what happens at 1? F prime at 1 does not exist. That's a definition of a critical point. Okay, so be careful there. We didn't have any solutions from 0 equals, but we do know that it is undefined and does not exist at 1. So that's a critical point. Okay, so
I'm sorry, on the bottom, is that to the 1/3 power or times this the 1/3 power?
yeah, 1/3.
It's the 1/3.
Yeah. Okay, so calculate the max values. I'm pretty sure they would land the plane and arrest you. I hope they ship you to Oklahoma. No, better yet, Nebraska. Okay, can we continue, Ben?
Yeah.
Thank you for hijacking calculus class. Ha, you get it? Hijacking airplanes. Who has my values?
2.5870.
Wrong. Okay, everybody, right now, do this calculation. Because 2 people now have got it wrong. Apparently, we need some order of operations help. Yeah, you did. You just had a crappy teacher. The original. We're maximizing the original, so.
And then 1 would be square on the inside.
Do. Ben, are you even doing this? Okay, what's -1, Ben?
Negative 0.5874. 192.
Okay, oh,
That's negative.
1 is 1 and 2 is, okay, what's my max? Maximum value, 1, okay? Do you want me to show you a sine cosine problem? If you were asked for it, it only asked for the max.
-1 minus 1 is different from -2. I'm sorry. I'm sorry, I'm just so mad. I just calculated and
I get it.
Do you want to see a sine cosine?
Sure.
Okay, 1 person.
Ruby shoes are stolen from me when the gas lamp died.
All
All right, Dorothy. I have no idea what they're talking about, so.
She said if she quit her days and that she could go home. I said the shoes are stolen. Where's your house?
Okay, critical points. Everybody do the derivative. I'm gonna pick somebody at random. But we already know who that's gonna be.
Yeah, right.
But is it gonna be?
Inside negative cosine. Get that. Have you had this class too? The one was to us. Oh, it is. What was it possible
You can't sort through them, you just pick one.
Yeah. Who takes that? That's bias.
I do, that's what I chose. Allie Kelly. No, I'm trying to find,
Then?
a couple of people in here that's. Well, I got the picture, so.
Oh, did you? And where was that one?
Yeah, he came along there. John Smith, I know.
You had to. Oh, so we'll put it on the outside.
All right, here we go. Jet.
Jedediah.
Seven.
Jedediah.
Try again.
You're close. Negative cosine x, sorry. It's cosine x minus, that's a chain rule. Outside copy inside times derivative of inside makes that positive, right?
Wait, it's still minus, right? Negative something.
Negative x.
Got it.
That was a plus.
You do have to get a bit creative sometimes in solving these trig problems. Okay, so I factored, guys, I factored. Now I have to split it up to those right there.
So why is it that if you're using numbers, you don't do the outside ones, but
Are you addressing me?
yeah.
What?
You know, if you were, let's say it was like it was a function and you took like a 2x out, why is it that you want to use the 2x, you just use the parentheses, and then this one you use the outside one?
So we're looking at 1 and 2.
I'm confused.
Like, if you look at the last example, or one of the last examples we did, oh, like, the very first one when you pulled out the 6 from the function. And we only used what was in the first one, we did 2 binary.
Because I can divide 6 out and it's,
I and pi over 6.
But if you were to divide something
And 2 pi and 7 pi over 6.
well, cosine x is a function that can equal 0, but 6 is a number that cannot equal 0, so that's the difference. Where is cosine 0?
1.
No. Pi over 2 and
And 3 pi over 2.
remember the graph looks like that. Right there, right there. How about subtract 1, divide by negative 2, where does sine x equal a half?
5 over 6 and 5 over 6.
So we have to evaluate. Well, I'm just listening to you guys. Yeah, no kidding.
Everything's 7 then.
7 pi over 6 is correct, but it's outside of our interval. Okay, so see, these can get kind of long and dastardly. Is 0, pi over 6, pi over 2, 3 pi over 2, 5 pi over 6, and 2 pi. And I probably should have put that one up here, but that's okay. That, if I'm in order, should be right there. Okay, what's the function at 0? Zero plus 1 is 1 at pi over 6. Make sure your calculators are in radians for these, please. We work in radians. Okay, those are the numbers. What's our max? And our min? Oh, that's not negative. That's negative. That would be another max. So you have 2 maximum values. Or maximum values in 2 spots. It's the same value, but okay. Last thing, Rolle's theorem. You can see why we didn't do all this yesterday. Rolle was a pretty smart guy. Yes. Okay, there's Rolle's theorem. So f has to be continuous and differentiable. If f of a equals f of b, so the y values are the same. So basically, I have 2 y values that are the same. This says that there's a number somewhere in here where there's a critical point. That's what Rolle's theorem says. If the y values are the same for those 2 endpoints, Corey, do you care to explain this to us? Okay. Then there's a critical point between them. So if the y values are the same on the endpoints, there's a critical point between them. What's the slope? 0. So you already know your max min then, right? The theorem actually says such that f prime of c equals 0, which meets that condition. Okay, let's just real quick do this. Okay, so we have to test both points. Okay, so the theorem says first, is f continuous and differentiable? It is a polynomial, so yes. Okay, what's f of negative 2? (16 minus 4 is 12. 16 minus 4 is 12. So that condition is met. Okay, so we automatically know there's a critical point between those. Okay. You have the tools to go find that, right?
Yes.
Do you want me to show it to you? No calculator. Okay, so you could go through and find that the critical points, there are actually 3 of them. No. It's 0, positive 0.7, and negative 0.7. Okay, you have the work written down, correct? From yesterday? Oh, that stinks. Okay, the rest of the time is yours. Let me know if you have any questions.